Let's look at the joint probability density function. 2015 Society of Actuaries Sample Exam P, Problem 77. A device runs until either of two components fails, at which point the device stops running. The joint density function of the lifetimes of the two components, both measured in hours, is f of xy equals x plus y over 8 for x between 0 and 2 and y between 0 and 2. Calculate the probability that the device fails during its first hour of operation. What do they mean by a joint density function? Let's talk first about the discrete case. Discrete random variables. Suppose we roll a 6-sided die and a 20-sided die. I have a 20-sided die. I actually have a 120-sided die. Let x be the roll on the 6-sided die and let y be the roll on the 20-sided die. Let f of x be the PDF for x and let g of y be the PDF for y. In other words, f of x is the probability that our variable x takes on that particular value, little x. And g of y is the probability that our variable y takes on that particular value, little y. So for example, f of 1 equals a 6, that's the probability of getting a 1, and g of 1 equals a 20th, that's the probability of getting a 1 on the 20-sided die. The joint PDF, f of xy, is the probability that x takes on that particular value x, and y takes on that particular value y. Again, for some reason our authors, Hogg and Tanis, would call this a probability mass function, because in their book that's the term they use when they're dealing with discrete variables. For example, find f of 417. This is the probability x equals 4 and y is 17. Well, you have a 6-sided die, the probability that you get a 4 is a 6th, and you have a 20-sided die, the probability that you get a 17 is 1/20th. So the probability that x equals 4 and y is 17 is 1/6 times 1/20th, which is 1 over 120. The marginal PDF is f of x, and that's the probability x takes on that particular value x. It's the sum over all y of f of xy. And the marginal PDF of y is g of y. It's the probability that y takes on that particular value, little y. So it's the sum of f of xy over all x. And again, Hogg and Tanis call these f1 and f1 of x and f2 of y. They would call these marginal probability mass functions because PMF is the term they use when they're dealing with discrete variables. So for example, suppose the joint PDF of f of x and y is given by f of xy equals x plus y over 21. This is where x can be 1, 2, or 3, y can be 1 or 2. Find f of 3, where f is the marginal PDF of x. Well, let's construct a table of the values of x and y. So again, where do these values come from? 221. All I'm doing is plugging in x equals 1 and y equals 1 into this formula, and you get 2 over 21. You do the same thing for all the values of x and all the values of y, and you end up with these 6 possibilities. To find f of 3, well, to find f of 3, it's the probability x equals 3. So you would sum up f of xy for x equals 3, and y can equal any value. So you'd sum it up for y equals 1 and y equals 2, and you end up with 9 over 21. So again, you're summing up f of xy for all values of y, and x equals 3. In general, find f of x, the marginal PDF of x. Well, f of xy is the sum over all y of f of xy, and that's just going to be 2x plus 3 over 21. And here's why. Because when you plug in, again, we're summing up. We want to find, we're summing f of xy over all values of y. So first, we evaluate this when y equals 1, and we get x plus 1 over 21. And then we evaluate it when y equals 2, and we get x plus 2 over 21. So when you add those together, you end up with 2x plus 3 over 21. In the same way, if you found g of y, the marginal PDF of y, you would sum up f of xy over all x. And when you take this formula and evaluate this at x equals 1, x equals 2, x equals 3, sum up what you get, you end up with 3y plus 6 over 21. Determine if x and y are independent. The variables x and y are independent if and only if f of x times g of y equals f of xy. Now, in this case, f of xy is x plus 21. F of x is 2x plus 3 over 21. G of y is 3y plus 6 over 21. And that is not the same thing as f of xy, which which was x plus y over 21. So x and y are not